Hello there, and welcome. I'm so glad you found your way here. Perhaps you've had a long day, or maybe you just like to fall asleep while thinking about the stars rather than counting sheep. Either way, this time is for you. There is nothing else you need to do, nowhere else you need to be. Just allow yourself to settle in. Let your body sink softly into rest, your breath begin to slow, and your mind grow lighter, as if gravity itself has softened. As you settle, let go of the day. Let its thoughts and worries drift away like clouds passing in a gentle breeze. Each breath you take can carry them a little farther away. A slow breath in and a long, soft breath out, feeling calmer with each passing moment. Tonight, we are going to take a gentle journey. We turn our minds to cosmology, the miraculous story of our universe. We will drift from the very first spark of light to the birth of giant galaxies. It is a tale of vastness, mystery, and wonder. You don't need to hold on to any of these ideas. You don't need to understand them fully. Just let the words wash over you. Some of what you hear may surprise you, or perhaps it will simply spark a gentle sense of curiosity as you drift ever deeper into sleep. Let these thoughts be like distant stars in the night sky, beautiful to gaze upon, but asking nothing of you. And if these calm explorations bring you a sense of peace, you might consider liking and subscribing. It helps others find their way here too, one sleepy soul at a time. But for now, just for now, let's begin. Let the world outside fade away. Let your focus soften. It is time to rest. Let your mind drift back through all of time, back to the very beginning. In the very first instance, after the Big Bang, the universe was not dark, and it was not empty. Instead, it was radiant. The early universe may have been filled with light so dense it behaved like matter. Imagine that for a moment. A cosmos filled not with emptiness, but with pure, brilliant light. The tiny particles of light, the photons, were packed so closely together that they could not move freely. They scattered constantly, colliding with particles of matter and with each other in a brilliant, chaotic dance. This dense ocean of light created pressure, almost as if light itself were a physical substance with weight and texture. The entire universe, in its earliest era, was a dazzling, roiling soup of charged particles, a glowing plasma far hotter than the core of any star that would ever exist. It was a time of blinding heat and pressure, a beautiful, uniform brilliance stretching in every direction. For its first few 100,000 years, the universe was this beautiful, glowing fog of particles. Electrons and protons drifted free, and they scattered the photons so completely that light could not travel. Space itself was opaque to vision, but the universe does not stay still. It expands, and as it expanded, it also cooled, ever so slowly, over hundreds of thousands of years. The cosmos cooled. As the temperature dropped, a profound change began to happen. Around 380,000 years after the Big Bang, it became cool enough for electrons to finally settle into orbits around protons, forming the first atoms. And with the electrons now bound within these atoms, the photons were suddenly released. The fog cleared. In that single, quiet instant, the universe became transparent, and the light we call the cosmic microwave background began its journey. That ancient light, that first light, is still traveling today. Over time, as the cosmos has continued to expand, this light has been stretched out, its energy softening. Billions of years ago, this radiation was still warm enough to glow in visible light. Had we been there, the entire sky would have shone with a fiery orange glow. Now, that light has cooled and stretched so much that it is invisible to our eyes, becoming the cosmic microwave background that still surrounds us today. That faint glow is the stretched out remnant of a universe once so bright it behaved like matter itself. When we measure that ancient, peaceful glow, we are seeing the exact moment the universe first let its light go free, a timeless after image of a cosmos lifting its primordial veil. The universe began, and it began to grow. This expansion is the gentle, constant rhythm of our cosmos, but it has not always been the same. The speed of cosmic expansion has changed more than once. In its very first fraction of a second, something incredible happened. An idea known as cosmic inflation suggests that the universe expanded faster than the speed of light. In a mere blink of an eye, the cosmos grew from a size smaller than an atom to larger than a galaxy. This incredible stretching smoothed out the fabric of the cosmos, making it astonishingly flat and uniform. The inflation theory explains why distant parts of the universe, which have never had time to be in contact, look so very much alike. They were once connected, and inflation carried that sameness across unimaginable distances. But what if that inflation never truly stopped? According to some models, inflation didn't stop everywhere at once. Instead, it may continue eternally in distant, faraway pockets of space-time, constantly creating new regions of space forever. In this beautiful picture, our own universe is just one single bubble among countless others. Each new bubble would expand so quickly that no light could ever cross the gulf between them and us. They are forever cut off from us. We will never see those other regions, never touch them, and yet they might exist, endlessly budding and blossoming into the void. To think that our entire observable cosmos, with all its trillions of galaxies, could be just one finite blossom on an infinite, ever-growing tree is both deeply humbling and strangely beautiful. This expansion creates a limit to what we can see. As we look out into the sky, we are also looking back in time, but there is a boundary, soft edge called the cosmic horizon. Beyond this line, light has simply not had enough time to reach us since the Big Bang. Those regions of space are real, filled with galaxies and stars, but they are forever hidden from our view. It is not a wall, but a limit of our perspective, like standing on a shore and seeing only as far as the curve of the earth. Every year, as more ancient light arrives, that horizon grows a little bit larger. Yet, at the same time, the expansion of space itself is pushing other, more distant regions away from us, faster than their light can travel toward us, causing them to slip beyond our view forever. The cosmic horizon is a quiet, gentle reminder that no matter how far our telescopes can stretch, there will always be more universe beyond, forever out of sight, and there are hints of things beyond that horizon. Astronomers have noticed that some galaxies seem to be tugged along by a hidden influence, something lying far beyond the part of the universe we can see. This strange shared motion has been nicknamed the dark flow. It may be caused by enormous, unseen masses that exist outside our cosmic horizon, invisible to us, but powerful enough to bend the paths of entire clusters of galaxies. We cannot see these hidden regions directly, but we can see their gentle fingerprints in the motions of the galaxies that are closer to us. It is a haunting reminder that the universe we can observe is just one small patch of something much, much larger, and that unseen structures may still be shaping the cosmos we live in. The universe is not uniform. As you drift and dream, you can picture its grand structure. Galaxies are not scattered about randomly like dust in a sunbeam. Instead, they form vast, intricate patterns, beautiful threads, great walls, and delicate filaments of light. Together, these structures form what is known as the cosmic web. It is a pattern that resembles the delicate strands of a spider's web, or perhaps the branching filaments of neurons in a brain. Superclusters of galaxies containing hundreds or thousands of individual galaxies stretch for hundreds of millions of light years, linked together by these glowing filaments. And between these filaments lie immense, empty regions called cosmic voids. One of the most extraordinary of these structures is the Boss Great Wall. It is a sprawling, breathtaking chain of superclusters that extends across nearly a billion light years. Within this magnificent structure, countless galaxies are strung together like glowing beads on invisible strings of dark matter. To put its incredible scale in perspective, if our own Milky Way galaxy were just a single dot of ink on a map, this great wall would stretch across entire pages. Our own galaxy, the Milky Way, lives within the Laniakea supercluster, a sprawling region that contains hundreds of thousands of galaxies. We are part of this web. When we map these incredible structures, we see not chaos, but a deep and profound elegance. We see gravity itself, quietly sculpting luminous threads across the universe, revealing a hidden order that spans billions upon billions of light years. And this web continues to grow and evolve over billions of years. Gravity gently draws more and more galaxies along the filaments, making them denser, while the cosmic voids grow even emptier and larger. The cosmic web is not a static thing. It is alive, a dynamic architecture that is slowly sculpting the fate of all the galaxies within it. Even now, as you rest, our own Milky Way is drifting quietly along its filament, carried along in the great cosmic tide, part of a pattern so vast it is almost beyond imagination. These structures remind us that the cosmos is not just vast, but also deeply patterned, a kind of silent architecture on the grandest imaginable stage. Even now, the universe is filled with quiet echoes from its first moments. Faint whispers of creation are still streaming through the cosmos, and even through you, right at this moment. Think of neutrinos. They are ghostly particles, almost without any mass, that very rarely interact with matter. Right now, as you lie here, trillions of them are passing through your body every single second, completely unnoticed. Many of these are created in the sun or in distant, dying stars, but some of them are unimaginably older. In the very first second after the Big Bang, the universe was flooded with these neutrinos. Unlike photons, the particles of light, which were trapped in the hot plasma for hundreds of thousands of years, the neutrinos slipped free almost immediately because they interact so very weakly with other matter. They have been flying through space, undisturbed ever since, forming what physicists call the cosmic neutrino background. Though they are nearly impossible for us to detect, they are everywhere, including inside of you, right now. Each and every one of them is a tiny, silent relic of the universe's very first heartbeat, still whispering its secrets through the cosmos almost 14 billion years later. We have never seen this background directly, but we know it is there, a hidden window into the first second of existence itself, and there may be other, stranger relics. Theories predict that as the very early universe cooled, strange defects in the fabric of space-time itself could have formed. These are called cosmic strings. They are not made of matter at all, but are infinitely thin cracks or wrinkles in space-time, potentially stretching for billions of light years across the cosmos. If they exist, they would be like scars left over from the universe's own birth. There are also ripples in space-time itself, known as gravitational waves. We have detected these waves from massive events like two black holes colliding, but there may be far, far older waves, born in the very first instant of the universe's existence. During cosmic inflation, space-time itself may have shivered with tiny quantum fluctuations, stretching those ripples across the entire cosmos. These primordial gravitational waves would be unimaginably faint today, but if we could ever detect them, they would be direct fossils of the universe's birth. They would carry us back almost to time zero. The cosmos may still be ringing ever so faintly with the vibrations from its own creation. Even the clustering of galaxies holds an echo. In the early plasma, there were sound waves, pressure waves moving through the hot soup of particles like ripples in a vast ocean. As the universe cooled, these waves left their imprint, freezing into the structure of matter. Today, we can still see their faint signature in what are called baryon acoustic oscillations, enormous ripples in the clustering of galaxies. It is the after sound of the universe's first moments, a cosmic hum that continues to shape the universe even now. As you drift, let your mind become aware of the vast, unseen universe. The stars and galaxies we can see make up only a tiny fraction of what is actually out there. Our best models tell us that about 95% of the universe is made of mysterious ingredients we have yet to identify. These are dark matter and dark energy. First, imagine dark matter. It is an unseen substance that doesn't shine or reflect any light, but we know it's there because we can feel its gravity. When astronomers simulate the growth of the universe, they find that ordinary matter alone isn't enough to form the beautiful cosmic web we see. Something unseen must be providing the gravitational scaffolding for it all. That something is dark matter. In these simulations, dark matter clumps together first, forming vast, invisible filaments that stretch across space. These filaments then guide the flow of ordinary matter, drawing it in to form the galaxies and clusters that we see. Our own Milky Way sits within one of these invisible filaments, like a single dewdrop caught on a vast, unseen spider's thread. We cannot see the dark matter directly, but we see its gravity at work everywhere, sculpting the grand architecture of the universe. Without it, galaxies would simply fly apart. One of the most powerful pieces of evidence for dark matter comes from a cosmic event called the bullet cluster. This is a place where two huge clusters of galaxies have passed directly through one another. The hot gas from the clusters, which makes up most of their normal matter, collided and slowed down in the middle, glowing brightly in X-rays. But when astronomers mapped the gravity of the clusters, they found that most of the mass kept on moving, passing right through the collision without slowing down. This showed that most of the mass was not in the hot gas, but in something invisible and non-interacting. dark matter. Then there is dark energy. This is the mysterious force that is driving the accelerated expansion of the universe. For billions of years, gravity was slowing the expansion down. But a few billion years ago, the expansion started to speed up again, pushed by this strange, gentle pressure that exists in empty space itself. Because dark energy makes up most of the cosmos, its behavior will determine everything about the future. We do not yet know if it is constant or if it might be changing with time. The entire fate of the universe rests on the hidden nature of this invisible force. It is possible that the accelerating expansion of the universe is driven by the energy of the quantum vacuum, the restless sea of particles blinking in and out of existence in even the most empty space. What we call nothing may be the most powerful something of all. After the universe became transparent, it was dark. For hundreds of millions of years, there were no stars to shine. This period is sometimes called the cosmic dark ages. The universe was filled only with vast, peaceful clouds of neutral hydrogen and helium gas. But slowly, ever so slowly, gravity began to work its magic. Within those clouds, the gas began to gather into dense clumps, and then the first stars ignited. These first stars were nothing like the stars we see in our sky today. They were formed from only hydrogen and helium because there were no heavier elements yet. Without those heavier elements to help the gas cool, the clouds that formed the stars grew enormous, hundreds of times the mass of our sun. They would have been incredibly bright, blazing with an intense white-blue light. But because they were so massive, they lived fast and died young. In only a few million years, these giant stars, known as population 3 stars, burned through all of their fuel. In their fiery cores, they forged the very first heavier elements the universe had ever seen. Elements like carbon, oxygen, and iron. When these giant stars died, they died in spectacular fashion, scattering all of those newly created heavy elements out into space. They seeded the surrounding gas clouds with the raw material needed for the next generation of stars, for planets, and eventually for life. Though none of these magnificent first stars remain today, every atom of carbon in your body may have once been born inside one of these long vanished giant stars. The light from these first stars and galaxies brought an end to the cosmic dark ages. This period is called the era of ionization. The newborn stars and quasars flooded the universe with powerful ultraviolet light, which was energetic enough to break the hydrogen atoms back into ions. This process carved out great bubbles of transparency in the fog of neutral gas, and eventually, those bubbles merged until the whole universe was lit up once more. When we look at the most distant galaxies today, we are catching a glimpse of that cosmic dawn, the moment when darkness finally gave way and the universe became illuminated from within. The most massive of those very first stars had a dramatic fate. They ended their short lives in a total collapse. Their gravity was so overwhelmingly strong that when their fuel finally ran out, no force in the universe could stop them from imploding under their own weight. Some of them collapsed directly into black holes. These were unique black holes, not the corpses of ordinary stars, but the direct descendants of the first cosmic fire. It's possible that these first black holes acted as seeds growing over billions of years to become the supermassive black holes that we now find anchoring the center of almost every large galaxy, including our own. So, The brilliant quasars we see at the very edge of the observable universe, powered by black holes a billion times the mass of our sun, may trace their lineage all the way back to those very first collapsing stars. Born in the dawn of time, black holes are often thought of as the graves of stars, but some of them might be even older than any star. Cosmologists have proposed the idea of primordial black holes, which may have formed in the chaos of the very early universe. If the density of matter in that fiery first second was not perfectly smooth, whole regions of space could have collapsed under their own gravity, forming black holes before atoms or stars ever existed. Such black holes would be incredible relics, carrying with them clues about the conditions right after the Big Bang. They could be as tiny as mountains, or even as small as atoms, or as massive as stars. They might still be drifting invisibly throughout the cosmos today, like hidden fossils of creation itself. If they exist, they could even make up some or all of the mysterious dark matter that holds galaxies together. Black holes are not always solitary. In the dense centers of galaxies, they can be drawn into pairs, slowly spiraling closer and closer to each other over millions of years. As they spiral, they radiate energy away in the form of gravitational waves, ripples in the very fabric of space-time. Eventually, they merge into a single, larger black hole in a cataclysmic event that sends a final, powerful burst of these space-time ripples out into the cosmos. Over billions of years, these mergers may be how the supermassive black holes at the centers of galaxies grow to their enormous sizes. But even black holes may not be eternal. The physicist Stephen Hawking showed that they are not perfectly black. Due to quantum effects near their event horizon, they slowly emit a tiny amount of radiation, which is now called Hawking radiation. This radiation slowly saps their mass, causing them to evaporate. For the black holes that exist today, this process is unimaginably slow, but given trillions upon trillions of years, in the far distant future of the universe, they will eventually evaporate completely, leaving behind nothing but a final, faint whisper of radiation. Even the most massive black holes will one day fade away, gently dissolving back into the quiet stillness of the cosmos. As we continue to drift, let's bring our focus a little closer to home, to our own galaxy and our small place within it. Though the night sky looks peaceful and still, our galaxy is on a ceaseless and incredible journey. The Milky Way, along with all of its billions of stars, planets, and beautiful nebulae, is drifting through the cosmic web at a speed of more than 1,000,000 miles per hour. This motion is the result of countless gravitational pulls from nearby galaxies, from massive galaxy clusters, and even from vast, unseen structures in the universe. To us, this incredible speed feels completely invisible because everything in our local neighborhood is moving along together with us. There is no absolute rest in the universe. Everything drifts, everything flows, carried along on the great, silent, cosmic tide. Part of this motion is directed toward a mysterious region of space called the Great Attractor. This is a hidden concentration of mass that lies hundreds of millions of light years away from us, and it is gently pulling our galaxy, along with many others, toward it. Its true nature is still uncertain, but its pull is strong enough to guide the paths of entire galaxies, including our own. We are moving toward it, even now as you rest, carried along on the slow, invisible current of cosmic gravity. Even within our own galactic neighborhood, we have found that we live in a special place. Astronomers, mapping the gas and dust between the stars, have discovered that our sun lies within a vast cavity, a bubble that has been carved out of the galaxy's interstellar medium. This local bubble stretches for hundreds of light years across and is unusually empty compared to its surroundings. It was likely created millions of years ago by a chain of supernova explosions, which blew away the surrounding material and left this quiet, rarefied zone behind. Today, our sun and its neighboring stars drift peacefully within this bubble, bathed in the faint, warm glow of hot plasma from its edges. To think that our solar system resides inside the lingering footprint of ancient, long dead stars adds a strange and beautiful intimacy to our little place in the cosmos. Our galaxy is vast, but it is just one of an almost unimaginable number. Early estimates suggested there were hundreds of billions of galaxies in the universe, but deep images from telescopes like Hubble have revealed far, far more. Cosmologists now think there may be as many as 2 trillion galaxies in the observable universe. To put that number in perspective, if you could scoop up all the sand from every single beach and every desert on Earth, the number of grains would still be less than the number of galaxies in our sky. And each of those galaxies contains billions or even trillions of stars of its own. Each of those stars could host planets. When we gaze up at the night sky, we are seeing only the faintest, closest sprinkling of a truly overwhelming cosmic ocean. Let your mind now relax into the very fabric of reality itself, into space and into time. Einstein's theory of general relativity tells us that time and space are not separate things, but are woven together into a single fabric, space-time. And this fabric is not rigid. Its behavior depends on the presence of energy and gravity. This means that time does not always flow at the same rate. Near massive objects, where gravity is strong, time actually passes more slowly. In emptier regions of space, where gravity is weaker, it passes a little faster. On cosmic scales, this means the flow of time may differ slightly from one place to another in the universe. In the seething furnace of the early universe, where densities and energies were unimaginably high, time itself may have stretched, warped, or slowed compared to the steady flow we experience today. Some theories even suggest that what we call the beginning of time may not have been the true beginning at all, but merely a transformation from one state of being to another's. When we look back across billions of years of cosmic history, we may not just be peering through space, but also through changing, flowing rivers of time itself. And gravity, the force that shapes space-time, is itself a deep mystery. We think of it as a powerful, universal force, binding planets to stars and stars to galaxies. But when you compare it to the other fundamental forces of nature, it is astonishingly weak. A small, simple magnet can lift a paperclip against the gravitational pull of the entire Earth. Some physicists wonder if gravity only feels weak to us because it isn't confined to our familiar dimensions. Instead, it may spread out or leak into hidden extra dimensions that are unseen by us. If this were true, it would mean that the force of gravity we experience is only a faint echo of its true, deeper reality. These extra dimensions could be curled up so small that we can't perceive them, yet still be large enough to siphon away some of gravity's strength. It's a strange and beautiful idea that our universe could be part of something far more layered and complex than we can possibly imagine. Einstein's equations also allow for even stranger possibilities, like tunnels through spacetime that could connect distant regions of the universe. These are known as wormholes. However, to keep such a wormhole open, it would require a form of exotic matter with negative energy, something we have never seen in large quantities. Without it, any wormhole would collapse instantly. Even if nature never built one, they remain a tantalizing reminder that the laws of physics describe not just the universe we see, but also strange and wonderful possibilities that stretch our imagination to its very limits. Now, let's drift even deeper, deeper than stars, deeper than spacetime, down into the smallest scales of reality, where the strange and wonderful rules of quantum physics reign. Down here, empty space is never truly empty. It is a restless sea, simmering with quantum energy. Tiny particles constantly blink in and out of existence, borrowing energy from uncertainty itself before disappearing back into the void a moment later. This is the quantum vacuum, and it is from this quantum realm that everything we see may have been born. During the period of cosmic inflation, these tiny, microscopic quantum fluctuations were stretched to cosmic scales. They became slight, gentle ripples in the density of the very early universe. Over billions of years, gravity took hold of these tiny ripples and amplified them. It began to draw matter into the regions that were ever so slightly denser and away from the regions that were slightly less dense. From those incredibly small quantum seeds grew the galaxies, the stars, the planets, and eventually life itself. It is an astonishing and humbling thought to realize that everything we see in the night sky, from the glowing arms of the Milky Way to the most distant galaxy cluster, was born from a microscopic quantum jitter amplified by the vast machinery of cosmic expansion. Some theories suggest that the entire universe itself may have sprung from one such quantum fluctuation, a tiny tremor in the nothingness that was magnified by inflation into a whole cosmos. If so, our universe is a natural outcome of physics, a beautiful possibility realized from the endless chances of the quantum world. This deep connection between the very small and the very large has led to one of the most profound ideas in modern physics, the holographic principle. It suggests that everything we experience in our three-dimensional universe might actually be a projection of information that is encoded on a distant two-dimensional surface. Just as a flat hologram can contain the illusion of three-dimensional depth, the cosmos we live in may emerge from data that is written on a cosmic boundary. This idea suggests that space and time themselves may not be fundamental, but might emerge from deeper patterns of quantum information and entanglement. The deepest layer of reality may not be matter or energy, but pure information, endlessly recombining to give rise to the beautiful world we know. Let us return now to that ancient light, the cosmic microwave background. It is the oldest light we can see, a baby picture of the universe when it was only a few 100,000 years old. To our eyes, it looks almost perfectly uniform, a smooth glow across the entire sky. Its temperature is the same everywhere to an astonishing degree, varying by only 1 part in $100,000. But within that near perfection, our sensitive instruments have revealed tiny variations, strange patterns, and puzzling anomalies. One of the largest and most mysterious of these is known simply as the cold spot. It is a region of the sky where the temperature of this ancient light dips strangely and unexpectedly low. Some scientists suggest it may be caused by a massive supervoid, an immense region of empty space that lies in that direction, sapping a tiny amount of energy from the photons as they pass through it. But other, more exotic speculations suggest it could be the fingerprint of physics beyond our known universe, perhaps even the scar from a collision between our universe and another one in the distant past. Whatever its cause, the cold spot remains one of the most puzzling anomalies written in the universe's oldest light. There are other puzzles as well. The cosmic microwave background appears to be slightly lopsided. One side of the sky shows slightly stronger temperature fluctuations than the other side. This is puzzling because our models of the early universe suggest that it should have been nearly the same in every direction. Even stranger, some of the large-scale patterns in the microwave background seem to be aligned with each other along a common axis in the sky. This alignment, which has been playfully nicknamed the axis of evil, shouldn't exist if the universe is truly random and uniform on the largest scales. What makes it even more puzzling is that some of the largest cosmic structures we see, like the distribution of distant galaxies, seem to follow this very same orientation. No one knows for sure if these are just statistical flukes, a cosmic coincidence, or if they are pointing toward some deeper, unknown physics that shaped our universe in its earliest moments. They may be scars left over from a time before the Big Bang itself. These faint patterns in the ancient light are not just random noise. They may be the fingerprints of realities far older and larger than our own. They are gentle reminders that even after all we have learned, the cosmos still holds deep and profound mysteries. Every story has an end. And so, as we drift towards deeper sleep, we can gently wonder about the ultimate fate of our universe. Its destiny depends on its most mysterious ingredients, particularly dark energy. For now, dark energy seems to be steady, causing a gentle acceleration of cosmic expansion. If this continues forever, the universe is headed for a quiet and peaceful end known as the heat death. In the far, far future, trillions of years from now, all the stars will have burned out. The galaxies will have drifted so far apart that the sky will be completely dark. Eventually, even the black holes will have evaporated through Hawking radiation. The universe will reach a state of perfect equilibrium, cold, dark, and uniform, with no energy left to drive any change. It is not a fiery ending, but a slow, gentle fading, a dissolution into a perfect, timeless stillness. But what if dark energy is not constant? Some models suggest that dark energy could grow stronger over billions of years. If that were to happen, the expansion of the universe would accelerate more and more violently. Eventually, it would become so powerful that it would tear galaxies apart, then pull stars and planets away from each other, and finally, in the last moments, it would even rip atoms themselves apart in a catastrophic event known as the Big Rip. In other scenarios, dark energy could fade away or even reverse, allowing gravity to once again take control. If the pull of gravity is strong enough, it could eventually halt the expansion of the universe entirely and begin to reverse it. All the galaxies would slow their retreat, stop, and then begin to fall back toward each other. The cosmos would shrink, growing hotter and denser as everything rushed back together, ultimately collapsing in a final, fiery big crunch, undoing the Big Bang in a dramatic implosion. There is another possibility, one of endless renewal. Some cosmologists wonder if the universe is cyclic, destined to die and be reborn over and over again. In this view, our universe might collapse into a big crunch, but from that collapse, a new Big Bang might arise, beginning the cycle all over again. This idea is sometimes called the Big Bounce. If it is true, then our universe is not the first, but just the latest in an endless, beautiful chain of cosmic heartbeats. Creation and destruction become part of an eternal rhythm, with no true beginning and no true end. We do not know which of these futures awaits our cosmos. The largest answers may lie hidden in the smallest particles we have yet to discover. For now, we can simply rest, knowing that we are part of a grand story, a story that is still unfolding into an unknown and mysterious future. As our journey nears its end, let us allow our imagination to drift one last time beyond the edges of our own cosmos. The theory of eternal inflation, which we touched upon earlier, suggests that our universe is just one bubble that formed when a region of space stopped inflating, but other regions may have kept expanding, forever spawning new bubble universes. Each of these bubbles could be infinite in size, and together they would form a multiverse without end. In this breathtaking picture, our Big Bang was not the beginning of everything, but simply the birth of our own local region of reality. Other universes may lie forever beyond our reach, each with its own galaxies, its own stars, and perhaps even its own unique laws of physics. In one universe, gravity might be so weak that stars could never form. In another, the forces might be so different that atoms themselves could not exist at all. This raises a haunting and beautiful possibility. Our own universe appears to be finely tuned, with its physical constants balanced on a razor's edge in a way that allows for complexity to arise. If the strength of gravity or the charge of an electron were even slightly different, the cosmos as we know it would not exist. Stars might not ignite, or galaxies might collapse too quickly for life to ever have a chance. Perhaps we simply live in one of the rare universes among countless others where the conditions just happen to be right for observers like us to exist. It's a vision of reality so incredibly vast that even our observable cosmos, with its 2 trillion galaxies, would be just one small, gentle ripple on an endless cosmic sea. We may never know for certain whether our cosmos is the only one. The multiverse is one of the most tantalizing ideas in all of science, but by its very definition, these other universes may lie forever beyond our reach, cut off by cosmic horizons that we can never hope to cross. And perhaps that is okay. The fact that the universe inspires such questions, that it invites us to wonder about realities far beyond our own, is itself a profound and beautiful gift. To live in a cosmos that holds such deep mystery is to live in a place where imagination and science can meet, stretching out toward infinity together. And so, our long and peaceful journey through the universe draws to a quiet close. We've drifted across billions of years tonight. We have felt the first hot glow of the primordial plasma, and we have listened for the faint, ancient whispers of primordial vibrations that still echo through the vastness of space. We've wondered at the soft horizons we cannot cross, at galaxies born from ripples smaller than a thought, and at the humbling possibility that our cosmos is only one among many. Cosmology reminds us, in the gentlest way, that we are woven into something truly vast, something that began long, long before us, and will continue long, long after we are gone. And yet, here you are, breathing softly in this present moment, carried by the very same laws of physics that guide the silent dance of galaxies and stars. Every quiet heartbeat, every gentle breath is a part of that grand and ancient story. So now, just let all the questions drift away. Let them go, like tiny seeds on a gentle stream. There is no need to hold on to them any longer. The universe will go on turning, stretching, and singing its quiet, cosmic song, whether you're thinking about it or not. You can simply rest now. Rest in the knowledge that you have touched its mystery tonight. Thank you for sharing this quiet journey with me. If you have enjoyed this time, you can gently like, subscribe, or perhaps leave a peaceful thought in the comments below. It helps others find their way to this restful place too, one sleepy soul at a time. But for right now, there is nothing more to do. There is nothing more to think about. Just allow your body to sink even deeper into rest. Let the day fall completely away behind you, and let the calm widen within you, like the vast, open, and peaceful night sky. The universe is vast, and so are you. Sleep well, sleep deeply, and I will see you in the next journey.